So today we are going to discuss about the frictional stresses and shear stresses. But before going into these topics, these stresses, you need to understand what is shear force and bending moment and how to calculate them. Okay. Of course, you are going to learn in detail about shear force and bending moment, but here we are going to see them briefly. Okay, so I'm going to solve few examples explaining how to draw the shear force and bending moment diagram also. Okay, I'm going to teach you, explain you how to calculate shear force and bending moment and also their diagrams. Of course, once we go into this lecture, you are going to have a good idea. Okay, so this is the syllabus that we are going to discuss as a part of our unit 2. Okay, fractional stresses and shear stresses. So let me just dive into that. So as you know, these are the good textbooks that I'm going to refer to you by Rajput Strength of Materials and Ramamrutam and R.K. Bansal. Okay, so let's go. So you need to know what is a beam. Of course, you know how a beam looks, but you need to know what a beam actually does. How a beam is different from a column or some other structural member of a building. Okay, so as you know, a building is a combination of structural members. Okay, so what are the structural members in a building? Columns, beams, isn't it? Foundation footings, slab. Okay, so beam is a part of that structure. So any structure is going to have a beam, is going to have a column, is going to have a slab. Of course, sometimes we may have to call it as deck in case of bridges, but it's a kind of similar to slab. And everything has to have a foundation footings, isn't it? So now we are going to see the beam in this part of unit. So what is a beam? A beam is nothing but a structural member which is long when compared with its lateral dimensions. So as you can see, this is the length. Length is the largest dimension, and this is width B, and this is depth D. So as you can see, these two are the lateral dimensions. So a beam is going to have a length which is very much high compared to its depth and width. So ఒక బీమ్కి ఏముంటుందని డెప్త్ విడ్త్ ఆర్ గోయింగ్ టు బి వెరీ మచ్ స్మాలర్ కంపేర్డ్ టు ఇట్స్ అదర్ థర్డ్ డైమెన్షన్ లెంత్. And this is the nature of loading. This is the nature of loading. So as you can see here, these loads are acting perpendicular to the length. Isn't it right? So that is why we call these as transverse loads. Okay, these are acting across the length. Okay, that is why we call these as transverse loads. So based on this, now we can define a beam, isn't it right? So here, as you can see, a beam is nothing but a structural member which is long when compared with its lateral dimensions, that is width B and depth D, subjected to a transverse forces or loads applied as to induce bending of the member. Okay, so what is happening is when the forces are acting on this beam, so this beam is going to bend in this manner, isn't it? Okay, so finally the forces are responsible for the bending of the beam. Okay, so this beam is nothing but a structural member which is long compared to its lateral dimensions and carries these transverse forces. Okay, so now let us jump to the objective of this unit. So in this unit, we are interested in finding out the stresses and strains because of those transverse forces, because of transverse forces or loads. Okay, but before going to that, you need to understand what is a shear force and what is a moment or a bending moment. Okay, so when a beam is loaded by forces or couples, stresses and strains are going to be created. We know that, right? But in order to find those stresses and strains, okay, we need to first find out what are the internal forces. Of course, we call this internal force as shear force, and this internally developed movement. Okay, because of the externally applied load. Okay, so our main aim is to find out these stresses. Of course, in order to do that, we need to find out the shear stress and bending moment. So let me go with the definitions here. Shear force is nothing but a force. Okay, so how do we calculate that? How do we define that? So as you can see here, shear force at any point or any section of a beam is going to be the algebraic sum of all the vertical forces acting on that beam, either to the left or to the right of that section. Okay, so here is a simple reason why we are defining the shear force at a section in such a manner. Okay, so as you can see, this is a beam and there are certain forces over here and here. This is a simply supported beam, simply supported. So this is the support here and this is the support over here. This is the span length L. You can call this as force P1 and this as P2. And this is section A and this is section B. This is C and this is D. There is a reaction RA here from the support, and here is the reaction RB at B. If I need to find out shear force at any section, here or here or here, just take this here. This is the section XX. And if I need to find out the shear force at section XX, I simply need to add all these forces on the left side of that section. Or, or I can also get the shear force at that section XX by adding all the right hand side forces. So as you can see, this is left side, this is right side. Okay, so add these all these forces over here. So shear force is simply denoted as SF at section X. X is RA and P1. Of course, you need to know the sign convention. Okay, so what is positive force and what is the negative? To which force you need to give positive and to which force you need to give a negative symbol over here. So let me briefly just see the sign convention. For left side, for left side, upward forces are taken as positive and downward forces are taken as negative. And for right side, downward forces are taken as negative and upward forces are taken as positive. Okay, so follow the sign convention of this over here. So the direction of RA is upwards. Of course, remember that we are taking on the left side. We are considering the left side of section, isn't it? So follow that convention over here. RA is upward, therefore it is positive, and P1 is downwards, so follow negative. Therefore, RA minus of P1, RA minus of P1 is the shear force at section 1 1. And similarly, you can also calculate the shear force at section XX considering the left hand side forces or left hand side of the given beam. Okay, so now let us say the bending moment at a section. Okay, so bending moment is also a little bit similar in the calculation to this shear force. So algebraic sum of all the moments because of all the forces acting on the beam either to the left or to the right is known as bending moment at that section. So as we seen earlier in the shear force is actually the sum of forces, but here the bending moment at a section is the algebraic sum of moments of those forces. Okay, about that section XX. So let me show you with a simple example as earlier. So this is a beam and this is the force P1 and this is the force P2. And here are the supports A and B. This is a simply supported beam and here is the section X. Now bending moment at section XX is nothing but the moment of forces, algebraic sum of moment of forces. So we have two forces on the left hand side, RA and P1, and on the right side we have RB and P2. So consider any one of the side of the section XX, either right or left. Let me first consider the left hand side, left side. So you have two moments. One moment is because of RA, which is equals to, if consider this as L1 and this as L2. So you know that moment is nothing but a force into displacement or force into distance. So RA into L1 is the moment of force RA about XX. And similarly, P1 into L2 is nothing but the moment because of load P1 about XX axis. So what is going to be the positive and what is going to be the negative? Clockwise, it is positive, and if the moment is anti-clockwise, it is taken as negative. So as we are seeing the equation for bending moment at section A, XX, RA into distance L1. This is L1, right? This is L1 and this is L2 and P1 into L2. So RA into L1 is actually clockwise, isn't it? This is clockwise. So it is taken as positive, and P1 into L2 is actually anti-clockwise, so negative. So this is with respect to x section, this is trying to rotate in this. The movement is in this direction. With respect to xx, the reaction RA and the movement because of RA is going upwards. The movement which is because of RA is trying to bend the movement beam in the upward direction, in the clockwise direction. The direction of the movement is clockwise, so positive, and this is negative. These are the different types of the beams that you are going to practically see out. So first one is cantilever. So cantilever is a beam with a fixed end or support only at one section and free at other section. So if a beam is held only at the one end firmly and the other end is free, it is called as a cantilever. And simply supported is nothing but a beam that is just placed over two supports. Let me just take. So there is a stone over here, there is a stone over here. So this is a ground, there is some grass, something like a park. And suppose there is a wooden plank put here, wooden plank, wooden plank, wooden piece. Okay. So this is something like a bench, isn't it? So when you sit over here, this bench is nothing but this wooden plank is nothing but a beam. Like this beam is made up of wood, isn't it? So these stones are nothing but supports. These are support. These stones are supports. See here. This is not fixed here, not fixed. And here it is also not fixed. So therefore, it is just placed over these supports. Just placed some మీద supports మీద అంతే. You did not fix it with some kind of bolts or in any other manner. You just placed it. If you wanted to lift that wooden piece, you can just lift it up. Okay, so this is what we call a simply supported beam. And remember that in our reinforced concrete design, when we are designing a building or any structure which has a beam, these beams are considered to be simply supported beams and they are designed. Okay. So now overhanging. So overhanging is nothing but a beam which has an overhanging portion. So as you can see, this is the overhanging portion. Overhanging portion. So if a beam is going to have this overhanging portion, and such a beam is called as overhanging beam, this portion. Okay. So what is a continuous beam? Continuous beam is a beam which has supports more than two, supports greater than two. See here, one, two, three, four. This is span one, span 2, span 3. Okay, so when a beam has supports more than 2, here it is 4. It can be 3, it can be 5, it can be 10. Okay, so if a beam has supports more than 2, it is called as a continuous beam. And as you can see here in the fifth one, a fixed ended beam, fixed beam. In case of fixed beam, the beam is rigidly fixed, rigidly fixed, rigidly fixed on both ends, both ends, on this end and on this end. Okay. And coming to this cantilever, simply supported, this is what we called as propped cantilever. Propped cantilever. So this is a cantilever beam which has a support, a simply support, a simple support. It has a simple support over here. Okay, so there is a similarity, isn't it? In the cantilever beam, one end of it is only fixed, and even in the proper cantilever, only one end is fixed. But in the cantilever, it is free here. But here in this prop, there is a support over here, a simple support, not a fixed support. Okay, of course, this support is going to exert a reaction. Some are. If you take this point as A and this point as B, and this reaction can be called as RB in the upward direction. Of course, cantilever beams cannot have larger spans. Okay, cannot have large spans. Because, for example, see here, if a load P1 is acting on this portion, if this beam has something like uh, L meters of length, the moment at section this here, moment at fixed end is equals to P1 into L1. The moment at the fixed end is going to increase with the length, isn't it? So far away the force acting, the greater is going to be the bending moment at the support at the fixed end. Okay, of course. So in such a case, you need to provide a large amount of reinforcement. Okay, so we just don't go for larger spans in case of cantilever beams. Okay, so now let us jump into the different types of loads. Of course, we have seen earlier these things, but let me just remind you for your revision. This is point load, uniformly distributed load, this is uniformly varying load, and this is concentrated movement. So point load is nothing but a load that acts at a particular location. Okay. But what is happening with the uniformly distributed load? In case of uniformly distributed load, the load is going to be distributed over the length. Don't be mistaken by this diagram over here. This uniformly distributed load can act anywhere, just somewhere between the two supports over a small length. Somewhere, anywhere it can be. Okay, it can start at any point and can end at any point, at any section of a beam. Okay, it is called as a uniformly distributed load. Of course, as said earlier, this uniform distributed load is presented in terms of Newton per meter. This load over here is nothing but the load present per 1 meter, per unit meter. Okay, if I say this is nothing but 2 meter, then total load is equals to W into 2 meter, because W is nothing but load per meter. Therefore, as the span is 2 meter, W into 2 will give you the total UDL force. And remember that this UDL always acts or concentrated or taken to be concentrated at the midsection of the loading. Okay, if this is the starting and this is the ending point of the load, what will be the midsection here? This is the location where the force is taken to be concentrated or acting. And if this is the force, okay, this is 1 meter, this is where this force is going to be taken as acting. And this is nothing but UVL. Of course, in the short form, you call this as UDL. This is UVL, uniformly varying load. So uniformly varying load, how it is going to be is, it is going to start with a minimum value. I mean, it cannot be zero all the time. It can start with a minimum value, something like 10 or 20 or 30, and it can vary linearly. Okay, it increases gradually up to a certain point. So sometimes this can be the type of uniformly distributed load. So this is uniformly distributed load. Something like here it is 10 units and here it is 10 units. Okay, units can be the units of force. So this can be, here it is started with 10 with the 20. So it starts with a minimum, it ends with a maximum. Or in some cases, it can start with a larger value and can end with a smaller value. Okay, so this is the load that keeps on changing, but it changes uniformly from one section to another section. And what do you call a concentrated movement? Okay, so let me just give you an example. So there is a bottle, and this is the cup of the bottle. And in order to rotate the cup, you apply force at two locations, at location 1 and location 2. This is the force over here. This is force. You use your thumb and index finger in order to rotate, right? So because of those two forces which are acting parallel to each other but opposite in direction and same in magnitude, this cup is going to rotate, and this is what we call as couple. couple, couple. So there are two forces acting together, so they are called as couples, and this couple is nothing but a concentrated movement. That is nothing but movement. So this couple gives rise to movement. Okay, so this is the distance between those two forces. So force into the distance between those two gives the couple. So this is how we represent it. So this is the couple that is acting at this particular location of the bay. Of course, we are going to solve some problems on this in the shear force and bending moment chapter. Let us consider this problem over here. This is a simply supported beam with the supports at A and B. And there are 3 point loads acting at C, D, and E at certain distance. Okay, so let us consider this and let us find out the shear force and bending moment at a given section. For example, let me consider a section over here, which is x at a distance of 6 meter. So I need to find out what is the shear force at this section, what is the bending moment at this section. So in order to do that, okay, so in order to do that, you first need to find out what are the reactions at support A, that is RA, and what is the reaction at support B, RB. Okay, only finding out these RA and RB, you can go to the finding out the shear force and bending moment. So how do we calculate these reactions? So as this is a simply supported, as this is SSB, simply supported beam, okay, the moment, or you can call it, okay, net moment is equals to 0 at supports A and B. Therefore, you can write the bending moment equation at A or B and equate it to 0 to get RA and RB. So I can write this. So consider A. So we are calling that the net movement at A is equals to 0. So what is the equation for movement at A? So find out the movement at A. At A, the movement is because of 5 kilonewton, 10 kilonewton, 8 kilonewton, and RB. Okay. And remember that if a movement is making the body to come saddy, it is negative. If it is becoming a smiley because of that movement, it is positive. Okay. So see here, it is very easy to give positive or negative symbols to that. Okay, so we have moment due to force 5 kilonewton, and we have moment due to 10 kilonewton, that is 10 into 9, and we have moment due to 8 kilonewton, which is 8 into 14, and we have RB into 15, isn't it? This is equals to 0. The algebraic sum is equals to 0. As you can see here, give the symbols according to their directions. So this is given as, so see the direction which it is trying to move in clockwise direction, of course, but what is happening here is About point A, this 5 kilonewton is actually trying to bend this beam downwards. Okay, downwards. Okay, so what we need to do is you just give the negative symbol over here, and similarly to this and to this, and positive symbol to this because it is acting upwards. So even it is anti-clockwise, this RB is trying to bend the beam upwards. Okay, if this is the beam, if a moment is trying to bend it upwards, it is going to get this shape, smiling, isn't it? So positive. So now on solving this, you get, let me write this equation again. This is equals to minus 20 minus 90 minus 112 plus 15 RB equals to 0. And you can add these 90 plus 20 minus 112 give rise to 222 plus minus 222 plus 15 RB equals to 0. So on solving, you get RB is equals to 222 by 15, which is equals to something like 14.8 kilo Newton. So this is how you find out RB. So you know RB, isn't it? Now you need to know RA. So I said to you earlier, this the sum of forces acting upward, that is RA plus RB, is equals to, these are the forces acting upward, is equals to the forces that are acting downwards. So RA plus RB is nothing but 23 kilonewton. So RA is equals to 23 minus of RB, which is equals to 23 minus of 14.8. So you are going to get this is something like 5.2 and this is therefore 8.2 kilonewton is the reaction. Okay, isn't it? So this is simple. It is very simple to calculate these forces, I mean these reactions over here. Okay, so let me show you the calculation over here. So now let us consider a section XX at a distance of 6 meter from the left hand support A. So now calculate the shear force at section XX. So as I told you earlier from the definition, so the shear force XX is obtained by adding all the forces on the left hand side or on the right hand side. Consider any one thing. So this is left side, this is left side, and this is right, isn't it? So consider only one of these two, either left or right. So let me consider left and also the right later. Okay, so now shear force at section XX is equals to, what is that? Algebraic sum of all the forces on the left hand side. So let me just remind you, what are the forces on the left hand? RA acting upward and 5 kilonewton acting downward. You know what is RA, right? 8.2. So which has to be taken positive, which has to be taken negative? I told you earlier here, for left side, upward is positive, downward is negative. For right hand side, if you consider the right side, so you need to follow this convention. What is that? Downward positive, upward negative. So I'm considering the left hand side of that section, therefore follow this convention. So upward positive, downward negative, therefore plus 8.2 kilonewton minus 5 is equals to plus 3.2 kilonewton. What should be the direction of the 8.2 is the greater value, it is acting upward. So 5 is acting downward. So the net force, the algebraic sum, is going to act upward, and that is why it is positive also. Okay, upwards. And now, similarly, I can calculate the shear force at section XX by considering the right hand side, right side. This is left and this is right side. So if you see here, what are the two forces present? I mean, three forces present: RB and 8 and 10. So find these two. I mean, find the sign convention that we are going to use. This is the right side. So downward is negative, sorry, positive. So 8 and 10 are downward. So these two are positive forces and RB is negative. Therefore, you get 14 minus 14.8 plus 8 plus 10, which is equals to minus 14.8 plus 18, which is equals to minus 3.2 kilonewton. Minus, in this sense, it is acting downwards. So if you see here, if you consider the left hand side portion, this is the direction of shear force, SF, and on the right hand side, this is the direction of shear force. Okay, so at this section, the shear force is 3.2. There is no change in the magnitude. Okay, there is no confusion about the magnitude of the shear force. But here, as you can see, the shear force is acting upward on this section, and on this section here, it is acting downwards. Just like rubbing your hands against each other. ఓకే, రెండు చేతులు, రెండు పామ్స్ తీసుకొని ఒకదాని మీద ఒకటి పెట్టి మీరు, if you move those palms of your hand in opposite direction, okay, what is happening is this: the shear forces are acting on each other because of the other body. Okay, the right hand is going to apply a shear force on the left, and left is going to apply on right. They are going to be equal in proportion, I mean equal in magnitude, but opposite in direction. So let me show you the calculation over here. So this is the shear force which we calculated at the section XX. On the left hand side it is positive 3.2, and on the right side it is minus 3.2. In the similar way, at that section XX, if you consider the left hand side, it is 39.2 kilonewton, and if you consider the right hand side portion, we are going to get minus 39.2 kilonewton meter. So let me show you the calculation for bending moment also. So before going into the calculation of bending moment, let me remind you that, okay, if the moment is clockwise, it is taken as positive, anti-clockwise negative. If a moment because of a force is clockwise, it is positive, and if it is a negative, I mean anti-clockwise, it is negative. Okay, so this is what we need to remember. Okay, on the left hand side or right hand side, on left or right side. So consider at section XX left side. Okay, we know that it is nothing but algebraic sum of all the forces. So we have two forces here, 8.2, and multiplied by distance between section XX. So here is the section, isn't it? This is the section XX, which is at a distance of 6 meter from here, and this is the 4, and this will be something like 2 meter. So, and the other moment is because of 5 kilonewton, 5 into 2. So this is the moment at section XX when you consider the left hand side. So what has to be positive and what is negative? So here, if you see, this moment is clockwise here because of this, so it is positive, and this moment 5 kilonewton into 2, 10 is negative because it is in anti-clockwise. So with respect to x, you have to measure, see the direction of forces. So if this is the section xx and this is the direction of force, okay, this is in the anti-clockwise direction, so it is negative. So which gives you some value in terms of kilonewton meter. Kilonewton meter is the unit of movement, you know that. So similarly at xx right side, if you consider, the movement at section axis is going to be because of three forces. The first force is 14.8 into its distance. What is the distance? 9. So 9. So this is a moment because of 14.8 force. And next one is because of 8 kilonewton. So 8 kilonewton into the distance. So total is 9. This is 1 meter. So this is going to be 8 meter. So 8 into 8. And similarly, we have 10 kilonewton, and moment due to 10 kilonewton is 10 into, what is this going to be? This is going to be 3 meter because total is 9. This is 5 plus 1, 6. So 9 minus 6, 3. Okay. So now what is the symbol going to be? So as you can see, 14.8 into 9 is the moment because of this, and this is in anti-clockwise. So put just negative, and these are positives, isn't it? See here, these are the moment due to 8 kilonewton and 10 kilonewton is in clockwise direction. Okay, so you are going to get some value, but these two values are going to be the same at section xx. Even if you consider left hand side or right hand side, the moment is going to be the same, but the direction is going to be different. Let me show you the calculation clearly. As you can see here, it is 39.2 kilonewton meter clockwise. Okay, so here this is the direction of movement, and here it is anti-clockwise. Okay, this is x section. So this is plus 39.2. This is minus 39.2. So this is how we find the shear force at a section and a bending moment at that particular section.